Hello everyone, Simon here. We're learning about psychology with Gemini, with Google Gemini. I'm having a great time actually. So last time we learned about anxiety disorders. This time let's look at mood disorders, and we're going to start with major depression because that's a pretty big thing. A lot of people have depression. All right, next I want to ask about next I want to move on to mood disorders. Let's start with the big one, depression. Um, what is happening in the brain of someone who has deep, who has actual clinical depression, as opposed to just someone being sad, to someone just being sad? In our previous discussion, we saw that sadness is a healthy temporary response to loss. Clinical depression, major depressive disorder, however, is a systematic power failure of the brain's emotional and cognitive systems. If sadness is a cloudy day, depression is a change in the entire climate. In the three-story house, depression represents a state where the penthouse cortex becomes sluggish, the living room limbic system becomes trapped in negativity, and the basement, the brainstem, lowers the body's overall energy voltage. The entire brain changes. The low voltage brain, prefrontal cortex. In clinical depression, the prefrontal cortex, PFC, our CEO, shows significantly reduced activity. So basically it makes you dumb, right? You stop thinking. Being depressed makes you stupid. Wow. Cognitive fog. Because the PFC is underactive, people with depression struggle with executive function. Tasks like deciding what to wear or focusing on a book becomes physically exhausting. Yeah, like you're literally stupid. You can't think anymore. Because your brain slows down, and so you can't think as hard. Loss of top-down regulation. The CEO loses the ability to overrule negative thoughts. In a healthy brain, the PFC can say, "This bad feeling will pass." In a depressed brain, that voice is too weak to be heard. Wow. The stuck living room, the amygdala and hippocampus. While the CEO is quiet, the emotional centers are behaving erratically. Hyperactive amygdala. Counterintuitively, the amygdala, the alarm, is often more active than depression. But instead of fight or flight energy, it produces a constant hum of low-level threat. This keeps the person in a state of chronic stress, right? So again, the stress. Stress harms you so bad. Like stress causes so much damage to your body. So you're constantly stressed. The shrinking hippocampus. Long-term depression is associated with a physical shrinking of the hippocampus, the librarian. This makes it harder to remember happy times or imagine a positive future. The brain literally loses the files for hope, right? So you can't remember the happy things. And remember from the last time, stress is cortisol, and cortisol shrinks the hippocampus. So like you're losing the ability to remember things. You're constantly stressed. You're not thinking straight. The neurochemical crash beyond serotonin. While we often hear about chemical imbalances, depression involves a complex cocktail of issues. The monoamine theory, the low levels of serotonin, mood, norepinephrine, energy, and dopamine, pleasure reward. Glutamine and GABA, the on-off switches of the brain become desynchronized, leading to a noisy brain that can't think clearly. The reward gap, the nucleus accumbens, the pleasure center, stops responding to things that used to be fun, a state called anhedonia. That's a lot of things. The body, the sickness behavior. The most striking thing about clinical depression is how it affects the body. The brain sends signals that mimic being physically ill, often called sickness behavior. You behave as though you are sick. Immune system, high levels of inflammation. A literal feeling of aching or being sick. Sleep-wake cycle, disruption of the circadian rhythm. Insomnia or sleeping too much but never feeling rested. The HPA axis, constant release of cortisol. Weight gain, digestive issues, and adrenal fatigue. Motor system, psychomotor retardation, moving and speaking in slow motion. Depression versus sadness summary. Healthy sadness lasts days to weeks, triggered by an event. Clinical depression lasts weeks to years, can be background noise, so you're just always sad. Physical effect, brief lethargy, crying is cathartic. So when you cry, you feel better. But in depression, there's chronic pain, exhaustion, and heavy limbs. You don't get better, I guess, after you cry it out. Self-esteem is generally intact, intense feelings of guilt or worthlessness. And then your brain is active in processing, or your frontal cortex. The CO is offline and struggling to manage. The path upward, neuroplasticity. The treatment for depression, like exercise, therapy, or medication, works by waking up the CEO. SSRIs help the communication flow. Exercise releases BDNF to regrow the hippocampus. Cognitive behavioral therapy creates new, stronger neural roads for the prefrontal cortex to drive on. Okay, so that's what's happening, but why? It doesn't say why that happens. But why does depression happen? Is there a genetic? Is there a genetic or epigenetic cause? Is there a trigger that begins a feedback loop? Is there some part of the brain or body that is malfunctioning to cause these things to happen? To answer why depression happens, we have to move away from the idea of a single malfunctioning part, and instead look at a perfect storm of biology, environment, and timing. Oh, it's complicated, I guess. It is really just one thing. It is a feedback loop where the body's defensive mechanisms accidentally turn against the brain. The genetic blueprint, the susceptibility. There is no single depression gene. Instead, there are hundreds of small genetic variations that make a person more or less sensitive to stress. The serotonin transporter gene, 5-HTTLPR. This is one of the most studied. Some people have a short version of this gene, which makes their amygdala more reactive to negative information. Wild. So, like, your brain is more reactive to negative information than other people. Like, some people are just negative. Like, they're just born negative because they have this gene. Can you believe it? I mean, like, different people have different personalities, right? But why? Partly it's genetic. Heredity. If an identical twin has depression, the other has about a 40 to 50% chance of developing it. This tells us that genes provide the vulnerability, but they aren't the whole story. 50% chance is a lot, right? Because, depression is not that common. It's kind of common, it's not that common. So if you have the same genes, it is much more likely than if not, right? Alright, epigenetics, how life turns on the genes. This is the bridge between your DNA and your life experiences. Epigenetics is a study of how the environment can flip switches on your DNA. So if you don't know, epigenetics is like your genes, your DNA is code, but attached to the code is the epigenes, is the switches, and the switches can change the way proteins interact with the DNA or the RNA. And so if you have the switches in place, sometimes the gene becomes deactivated, or if the switch is off, then the gene becomes activated. So epigenetics is these things that attach to your RNA to decide whether it's active or not, whether they actually have an effect or not. Wait, hold on. Do they attach to DNA or RNA? Maybe it's the DNA. But basically, if it's attached, then it blocks the transcription, and so it doesn't do anything. Does that make sense? I don't know if that makes sense. I don't want to get too deep into this. Early life stress. If a child experiences trauma, their body produces high levels of stress hormones. This can cause methylation, a chemical tag on the genes that control the stress response. Yeah, so it basically attaches a molecule to the gene. The consequence, the brain is effectively programmed to stay in a state of high alert. Even decades later, the brain thinks it is still in a dangerous environment, leading to the chronic shutdown we call depression. Wild. So once you like attach the tag to the gene, once the gene becomes methylated, it's always on. Or maybe it's always off. Is it off or on? Who knows? The trigger and the feedback loop. Depression often begins with a trigger, loss of a job, a breakup, or chronic illness. In a healthy response, the brain recovers. In depression, a vicious cycle begins. The trigger, stress causes the hypothalamus to signal for cortisol, right? The damage, high cortisol begins to wither the connections in the hippocampus, the librarian, right? Failure of perspective, because the hippocampus is struggling, the prefrontal cortex can no longer find memories of times things felt better. You can't remember the happy times. The social withdrawal, the person stops seeing friends. This lowers dopamine and oxytocin, which further starves the brain of positive signals. The loop. The brain interprets this low-energy, isolated state as sickness and triggers more inflammation, which makes the person feel even more tired. So that's the feedback, right? You get stressed, you feel bad, and then feeling bad, you withdraw from the things that would make you feel good. So you continue feeling bad, and then you get stuck feeling bad. But it's not just that, because there are genes that make you more susceptible to feeling bad, like, right? Makes the amygdala more reactive to negative information. So you're already susceptible to feeling bad, and then you get stuck in a loop. The malfunctioning system, the neuroinflammation theory. One of the most exciting and sobering areas of modern research is the link between the immune system and the brain. Brain as sick. When you have the flu, you feel lethargic, lose your appetite, and want to stay in a dark room. This is sickness behavior caused by cytokines, immune signaling molecules. The depression link. Many researchers now believe that chronic stress causes the brain's immune cells, microglia, to become stuck in an inflammatory state. The brain literally thinks it is fighting an infection that isn't there. It shuts down your energy and mood to save energy for the phantom fight. Right, because that's just stress response. Your stress response is your body tries to fight off something, right? But you're stuck in the stress response. Mm. So there's a lot of different things combined. Um, okay. So how is depression treated? You mentioned multiple factors combining can lead to clinical depression. This is a big question mark. Does this suggest there is not one single treatment that works for every case? Yeah, I mean, it's part like what is depression? You're sad all the time, right? That's depression. But if there's multiple possible ways for you to get stuck in this loop, does that mean that you have to figure out which particular loop it is to fix it? Like maybe there's a number of different things that can go wrong, and you got to figure out which one it is. Uh, do different people have different malfunctions? Do different people with depression have different malfunctions that require different treatments? You've hit on the most important realization in modern psychiatry. Depression is likely a symptom of many different underlying biological paths, not a single disease. That's crazy. It's not one thing, it's a lot of different things that cause the same symptoms. Wild. Because of this, two people can have the exact same symptoms. Sadness, fatigue, insomnia, but require completely different treatments because their malfunction is happening on a different floor of the three-story house. That's so complicated. Because it's like there's a loop, right? With different parts in the loop. And you can imagine like different people, like it could be different parts that are causing the problem. The trial and error reality. Currently, there is no brain scan or blood test that tells a doctor exactly which treatment will work. Most patients go through a process of trial and error because we are trying to guess which system is struggling. Awful. That's awful. I feel that's terrible. Anybody who has depression, that's terrible. The chemical imbalance, the synapse, the malfunction. The wires aren't communicating efficiently because there isn't enough serotonin or norepinephrine. Norepinephrine, yeah, norepinephrine. The treatment, SSRIs, Prozac or Zoloft, or SNRIs, Cymbalta, these act like chemical boosters to keep the signal flowing. Success rate works for about 30 to 50% of the people on the first try. So maybe about a third to a half of people, it is the chemical problem, and this fixes it. But like less than half. The structural problem, the hippocampus, the malfunction. Chronic stress has caused the pruning or withering of neural connections in the hippocampus. The treatment, exercise, sleep, and long-term SSRI use. These treatments increase BDNF, the miracle growth chemical, to physically regrow those lost connections. But most importantly, you have to stop stressing, right? Because it's the cortisol that's damaging the hippocampus. You have to one, stop stressing, and then you have to get the brain to heal. You have to like sleep enough and exercise enough to get the hippocampus to grow back. And so that takes time. The circuit problem, the communication gap, the malfunction, the penthouse CEO and the living room, the limbic system, have stopped talking to each other. The rational mind can't reach the emotional mind. Treatment is talk therapy. Cognitive behavioral therapy, is that what CBT is again? This is like physical therapy for the brain. By practicing new thought patterns, you are physically strengthening the neural pathways between the cortex and the amygdala. So you are actively training to think in a certain way, right? You're practicing thinking in a certain way to make your brain build up those pathways over time. Wild. New frontiers for treatment-resistant cases. For people where the standard chemical or therapy approach doesn't work, we look for deeper malfunctions. The electrical reset, TMS, transcranial magnetic stimulation, uses a magnetic coil to send electrical pulses into the dorsolateral prefrontal cortex. Dorsolateral prefrontal cortex? It's like jump-starting a dead car battery. It forces the sluggish CEO to wake up and start regulating emotions again. Right? Because the problem, if the problem is that your CEO, like your prefrontal cortex, I need to stop using this stupid analogy. Your prefrontal cortex is not is not talking to your amygdala. Yeah, so like your your prefrontal cortex is no longer trying to regulate your amygdala. And so you fix that by directly stimulating the prefrontal cortex with magnetic waves, with, like magnets, to just force it to start doing something. Uh, it forces the sluggish prefrontal cortex to wake up and start regulating emotions again. It's so funny. It's so magnets. Okay, magnets. Why magnets? Your blood has water in it, and water is slightly magnetic. And so when you put magnets on your brain, you can like stimulate blood flow. And there's a lot of water anyway. There's a lot of water in your body, and water is slightly magnetic. And so you can stimulate blood flow in parts of your body by using magnets. That's why. That's the magnets. The glutamate reset ketamine. While SSRIs take weeks to work, ketamine works on glutamate, the brain's main on switch. It can trigger a burst of new synaptic connections within hours. That's crazy. Also drastic. This is useful when the brain's wiring is so thin that it needs an emergency rebuild. Ketamine, you guys. Don't take ketamine without a doctor telling you to do it. It literally rewires your brain within hours, so it's very dangerous if you do it wrong. Alright, but apparently the brain is so sluggish and so, you know, not working that you literally take drugs to start it up again. The inflammation approach. Some researchers are now treating depression with anti-inflammatories. If the malfunction is actually an overactive immune system, the sickness behavior we discussed, clearing the inflammation in the body can clear the fog in the brain. Yeah, so that's part of the problem too. So the inflammation and the stress response. So if you just kind of turn that down, that can also help. Mm. Precision medicine, the future. We are moving towards a menu approach where treatments are matched to the specific malfunction. So anhedonia, the lack of pleasure. The malfunction might be dopamine or reward circuits. The targeted treatment, Wellbutrin and the RI or behavioral activation. So your behavior activation, you're just doing fun things, basically. Rumination, negative loops. Overactive default mode network. Mindfulness or ketamine. Meditation or drugs to stop the negative loops. Lethargy, physical heaviness, inflammation, norepinephrine, anti-inflammatories or SNRIs, executive dysfunction, low prefrontal activity, transcranial magnetic stimulation or stimulants, more drugs. Interesting. So there's a whole bunch of different ways for a person to become depressed. Would you like to explore bipolar disorder now? I would actually. Uh, Next, tell me about bipolar dis Is bipolar disorder. What is it? What is it? And what is happening inside the brain of a person with bipolar disorder? Bipolar disorder is essentially a disorder of self-regulation, while clinical depression is like a power failure. Bipolar disorder is a malfunction in the brain's thermostat. The brain loses its ability to maintain a steady emotional and energetic room temperature, causing it to swing between the extremes of cold depression and the scorching heat of mania. A disorder of self-regulation. In the three-story house, this is a failure of the prefrontal cortex to act as a governor for the limbic system. The manic state overvoltage. When a person enters mania, the brain's reward and arousal systems go into overdrive. The dopamine explosion. The nucleus accumbens, pleasure center, and the VTA flood the brain with dopamine. This creates a state of hyper-reward. Everything feels like a brilliant idea. Every risk feels like a guaranteed win. Everything is great, you guys. Alright, so you just... too much dopamine, and everything is great. The silent CEO, the orbital frontal cortex, this part, the part of the penthouse that weighs consequences, practically shuts down. We don't care about consequences. This is the YOLO symptom. This is why people in mania might spend their life savings or make impulsive, dangerous decisions. The brakes have been physically disconnected. Yep, YOLO. The amygdala on high. Instead of signaling fear, the amygdala in a manic state often signals excitement and aggression, leading to the irritability and high energy seen in the disorder. Right, so mania is that you're just happy. You are too happy. You are recklessly happy. Right? Excited, excitement and aggression. The depressive state, the crash. Eventually, the high voltage of mania becomes unsustainable. The brain's neurotransmitter supplies are exhausted, and the system crashes to protect itself. Alright, you run out of dopamine, basically. You dump all the dopamine, and then you run out. and then you crash. Synaptic fatigue. After being flooded with dopamine and glutamate, the receptors become desensitized. The grayouts. The brain enters the low voltage state we discussed in clinical depression. Lethargy, hopelessness, and the sickness behavior where the body shuts down to recover. The physical root. Why the swings happen? Yeah, why does that happen? We are still mapping the exact cause, but three biological malfunctions stand out, so we're not sure why. Mitochondrial dysfunction. Wow, we are getting into biology. Mitochondria are the power plants of your cells. In bipolar disorder, these power plants seem to be inefficient. They produce too much energy at once, then burn out, leaving the cells starved for energy, depression. So mitochondria is the part that burns sugar into energy. So they're the power plants in the cells. Sodium-potassium gate issues. Your brain runs on electricity created by salt, sodium and potassium, moving in and out of cells. In bipolar brains, these gates are often leaky. This makes neurons hyperexcitable, they fire too easily and too often. Reduced gray matter. Chronic swings can lead to a loss of volume in the prefrontal cortex and the hippocampus, making it harder for the brain to regulate itself over time. Amazing. So the mood swings damages the brain to make it harder to stop the mood swings. Wild. So it makes itself worse. Bipolar 1 versus bipolar 2, a spectrum of voltage. Not everyone with bipolar disorder experiences the same voltage. Bipolar 1 full mania can include hallucinations or delusions, psychosis. The CEO is completely offline. That's crazy. So like you're not thinking at all. You're hallucinating. Your brain is completely out of control. Bipolar 2 hypomania, high energy, extreme productivity, and decreased need for sleep, but usually no break from reality. Alright, so you're still aware of reality, but you have very high energy, right? Cyclothemia, mild swings, chronic low-level ups and downs that are less severe but persistent. Right, so this is a range of severity. Treatment, finding the stabilizer. Because the problem is instability, we don't just want to boost the brain, which could cause mania, or lower it, which could cause depression. We need lithium or anticonvulsants. Lithium, this simple salt, it works by stabilizing the electrical gates of the neurons and protecting the power plants, mitochondria. It effectively narrows the window of tolerance so the brain can't swing too far in either direction. Right, so lithium neutralizes. Alright, it brings you back to neutral. Hmm. Alright, so that's the mood disorders. That's depression and bipolar. I wonder if there's anything else we need to ask. Maybe this is just going to be a shorter. Hmm. Are there are there any other perhaps rarer mood disorders beside depression and bipolar disorder? While depression and bipolar disorder are the most common, there are several rarer or more specific mood disorders that reveal just how sensitive the brain's three-story house is to internal and external changes. In these cases, the malfunction is often tied to very specific triggers like light, hormones, or even passage of a single day. But how is that different from a normal person? Alright, so seasonal affective disorder. While many people feel the winter blues, seasonal affective disorder is a clinical disorder where the change in seasons trigger a full depressive episode. Wild. The malfunction. This is a basement brainstem issue. The suprachiasmatic nucleus in your brain's internal clock, relies on sunlight to regulate melatonin and serotonin. The glitch. In seasonal affective disorder, the brain overproduces melatonin, making the person sleepy and lethargic, and fails to maintain serotonin levels in the absence of bright light. It is like a hibernation reflex that gets stuck. Okay, but what's wrong with hibernating? What do you mean it gets stuck? Uh, Seasonal affective disorder, what you should know? I mean, when the weather improves, like when you get to spring, does it stop? It affects an estimated 10 to 20% of the population. Wow, that's a lot. 1 in 10 people is a lot. 1 in 5 is even more. Ways to reverse seasonal affective disorder. If you can't get outside during daylight hours, there are ways to help reverse your body's creation of too much melatonin. Absorbing natural full spectrum light regulates hormones in the brain and helps to keep your mood stabilized. In addition to obtaining a light box, 5 tips to help chase away the seasonal blues. Keep your holiday expectations realistic. Practice wellness. Stand in the sun. Yeah, stand in the sun. Cultivate some winter hobbies. See a doctor if natural interventions are not successful. Interesting. So not enough sunlight causes an imbalance in melatonin and serotonin. And one of the responses or one of the treatments is to get a light box. Get a box that gives you a full spectrum of light and just like bathe in the light for a while. All right, two, premenstrual dysphoric disorder, PMDD, is much more severe than PMS. It's a clinical mood disorder triggered by the hormonal shift in the second half of the menstrual cycle. They'll malfunction. It is not necessarily that the person has too many hormones, but that their GAGB receptors in the brain are hypersensitive to the fluctuation of progesterone and estrogen. The result, because GABA is the brain's calming chemical, this sensitivity causes the prefrontal cortex to lose control over the amygdala, leading to intense rage, despair, or panic for a few days every month. That's terrible. So you just get really angry or really sad when you have a period. Wow. Wow, it's real, you guys. It's not a, it's, it, women are not faking it. Some of them actually have premenstrual dysphoric disorder, and their prefrontal cortex loses control over the amygdala. Uh, right. Because the GABA receptors shut down because of the fluctuation of progesterone and estrogen. Right. Disruptive mood dysregulation disorder. This is a newer diagnosis primarily for children and adolescents characterized by chronic severe irritability and frequent intense temper outbursts. So like throwing tantrums. Wait, really? Tantrums is also a disorder? The malfunction. The brain struggles with social cognition. When a child with DMDD sees a neutral face, their amygdala and anterior cingulate cortex misinterpret that as a threat or a slight. Oh man. Like, sometimes the kids or even adults, like you look at them and they're like, what are you looking at? And you're like, I'm just looking around. Like, are you crazy? No, they're crazy. No, they're literally crazy. So So they see a neutral face as a threat or a slight. So you're just looking around and you like meet their gaze and they're like, what are you looking at? And then they think you're gonna start a fight when you're obviously not because you're not a crazy person. The conflict, it is a failure of flexibility. The brain gets stuck in a state of high arousal anger and cannot transition out of it when the situation changes. Huh. So they're always in high arousal. Persistent depressive disorder, dysthymia. Think of this as low-grade long-term depression. It isn't as intense as a major depressive episode, but it lasts for at least 2 years. Just sad, man. I'm just sad all the time. The experience is like a low-voltage hum in the background of life. The person can function, but they rarely feel joy. The circuitry. This is often linked to a numbing of the nucleus accumbens, the reward center. The brain isn't broken, but its volume knob for pleasure is turned down to 2 out of 10 indefinitely. Alright, so they're just not happy? They're just never happy. Postpartum depression and psychosis. This occurs after childbirth and is a combination of massive hormonal drops and extreme sleep deprivation. That sounds terrifying. So after you give birth, so giving birth is a serious disruption to your body. Massive hormonal drops and extreme sleep deprivation. The malfunction, the sudden drop in estrogen and progesterone by about 90% in 48 hours, acts like a chemical withdrawal on the brain. Wild. Oh, by the way, like when you have a baby, your brain gets hormones to want to like eat more and protect the baby and like your mood changes when you're pregnant. Not that I know because I don't get pregnant, but from what I understand. Like when a woman gets pregnant, right, the whole personality changes. And then apparently after you give birth, all that just goes away. Within 48 hours, that just goes. The extreme case in postpartum psychosis, very rare, but it does happen. The the cortex loses touch with reality entirely, often due to a perfect storm of sleep loss and dopamine dysregulation. And they go into psychosis, right? They just hallucinating and loses touch with reality. I mean, wow, right? So a combination of sleep loss and dopamine dysregulation because of the massive hormonal drops. That's terrifying. I don't know why women give birth. That sounds awful. Alright, so that's the other mood disorders. Okay. Well, let me end this video here. The mood disorder video. Next time we go to psychotic disorders and like schizophrenia, delusions, and hallucinations and other things. Alright, I'll see you next time. So interesting.